Welcome friends, I am Mr. Harshal Warade, Assistant Professor from Sanjani College of Engineering, Kopargaon. Today we will learn a new topic, that is interferometers part 1. This is the topic in Advances in Metrology unit number 3. So let us learn today interferometers part 1. Let us start from interferometry. What is interferometry? This question comes to our mind. Interferometry is a study of group of techniques in which the information about the electromagnetic waves is extracted by superimposing them and studying their various patterns. To understand the interferometry phenomenon, there is a need to study the nature of light. According to Huygens theory, the light is considered as motion of wave propagated in ether. Therefore, the light is considered as an electromagnetic wave of sinusoidal form. So the highest point on the wave is called as crest, whereas the lowest point of the wave is called as trough. So wavelength is the distance between the two consecutive crests or troughs. So what is the principle of interference of light? Interference of light. Let us see first of all interference of light. Monochromatic light source is the source of visible light of a narrow band wavelengths. Let us consider the principle of interference. If two rays of the same wavelength meet at some point, the mutual interference occurs and natural interference depends on the phase of two waves at their meeting point. See here, in the figure I have shown two waves of different amplitudes that are in phase. So if the two rays are in phase, then the resulting intensity will be the sum of the two intensities. If the two rays having the same amplitude are in phase, then the resultant will be the twice and the result will be the bright spot. When two waves of different amplitudes are out of phase by 180 degrees, then what is going to happen? If the two rays are out of the phase, the resulting intensity will be the difference of the two intensities, and if the two rays having the same amplitude are out of the phase, then the resultant will be 0 and the result will be a dark spot as shown in the figure. Finally we get the dark spot here. So interferometers make use of this principle of interference of light, and there are different types of interferometers. First one is Michelson's interferometer, second is Fabry-Perot interferometer, third is fringe counting interferometer, fourth is NPL Flatness Interferometer, fifth is Peter NPL interferometer, sixth is his gauge block interferometer, seventh is multiple beam interferometer, and eighth is laser interferometers. Let us learn few of them which are important from our interferometry point of view, metrology point of view. NPL flatness interferometer, let us learn today. I have shown the figure of NPL flatness interferometer. The NPL flatness interferometer is used for checking the flatness between the gauge surfaces. So as shown in the figure, the NPL flatness interferometer is shown. It is the schematic diagram of NPL flatness interferometer, and I have shown the two patterns here. First, A pattern is equal fringes on parallel. Second is B, unequal fringes due to the flatness error. Let us study this. Again see, I have shown some of the fringe patterns here where which are obtained by making use of NPL flatness interferometer. Now let us see the concept and working of NPL flatness interferometer. The light from a mercury vapor lamp is condensed and passed through a green filter, resulting in a green monochromatic light source. The light will now pass through a pinhole, giving an intense point of source of monochromatic light. Therefore, the collimating lens projects a parallel beam of light onto the face of the gauge to be tested via an optical flat. This results in the formation of interference fringes. The light beam, which carries an image of fringes, is reflected back and directed by 90 degrees using a glass plate reflector. Figure A. In figure A, the fringes are parallel and equal in number on the two surfaces. Obviously, the two surfaces are parallel, which means that the gauge surface is perfectly flat. It does not contain flatness error. On the other hand, in figure B, the number of fringes is unequal, and since the base plate surface is ensured to be perfectly flat, the workpiece surface has a flatness error. So here are few references which we can refer for further reading. Thank you.